Hey, welcome back. Which approach to deep learning will work best for the problems you're trying to solve? So you have a large collection of images, videos, audio recordings, log files, or other unstructured data, and you don't have time to figure out what the distinguishing characteristics of each class are? Then deep learning is a good approach. All of this processing does require a tremendous amount of computation. And this is why all the major cloud service providers have made GPU-accelerated platforms available. And this allows remote access to high-performance computing platforms that can process large amounts of data quickly without having to purchase all the expensive equipment. Now, if you're working on these types of projects, check out the Rapids open source platform. They really make this stuff easy to learn quickly. You'll drastically improve your productivity with near interactive data science. We're going to be going a lot more into Rapids AI in the very next series and how to further reduce your training time, so stay tuned for that. Okay, it can be helpful to think about deep learning as a way to map data samples from an input domain to an output domain. The input domain is your text, images, audio, video, even 3D images and data sets collected from medical image devices, geophysical analyses, cosmological models, and molecular dynamic simulations. And the output domain is then determined by the question you want to ask of the input data. And the question itself indicates the type of deep learning tasks you need to perform. So sandwiched in between these are the hidden layers, where you use this combination of tasks to achieve the sophisticated outputs of deep learning. Remember how if the question requires a yes or no answer telling you whether something is present, the task is detection, and if the question requires an answer describing what types of things are in each input, the task is classification? Well, for example, to automatically label all the faces in your family photos, you'd first need detection to find the faces in the pictures. And then apply facial recognition, which is a form of classification to determine the name for each face. Now, there are many readily available pre-trained deep neural network models, and often the best solution is a combination of multiple approaches with the output of one feeding into the next until you achieve the desired result. Then it's often necessary to modify and retrain these models to achieve the high levels of accuracy necessary for a particular data set or use case. But we're going to dive much deeper into the different deep neural networks and how to go about training them in another series. But for now, check out how this tremendous growth in deep learning this past few years is transforming industries in the last video of this series right here. Click, click. You can do it.